You know, whenever you look up at a clear night sky, it's so easy to feel like you're seeing the whole picture, right? Like you are witnessing the absolute totality of existence. Well, prepare yourself. We are about to completely shatter that illusion. Welcome to the invisible universe.
I am so ready for this, but honestly, where do we even start with a mystery this massive?
We start with what is, without a doubt, the single most shocking number in all of modern cosmology: 95%.
Wait, 95% of what exactly?
95% of the entire universe is just completely missing. It is literally undetectable. Okay, hold on. You're telling me that every glowing star, every galaxy, every planet, every single atom we have ever known or observed fits into a tiny 5% slice of reality? Exactly. That's it. The remaining 95% is entirely invisible to us. Physicists break it down into 27% dark matter and 68% dark energy. But look, just naming something is absolutely not the same as understanding it. This mystery is so overwhelmingly vast, it genuinely makes you wonder if the physics we've spent centuries building is even asking the right questions.
If it's completely invisible, how did we even figure out we were blind to most of reality? It's not like we could just point a telescope at literally nothing.
Right, we didn't. The story actually begins right here on Earth in the 1970s. It centers on a woman doing unglamorous, painstaking mathematics at a desk. Her name was Vera Rubin. She was measuring how fast stars orbit around the centers of spiral galaxies, and what she found permanently altered our entire understanding of the cosmos.
So, according to Newton's laws of gravity, objects further from the center of mass are supposed to orbit slower. Take our solar system, for example. Pluto moves way slower than Mercury. It's just basic physics. But Rubin discovered that stars at the extreme outer edges of galaxies were moving just as fast as the inner ones.
But wait, based on the visible matter, the stuff we can actually see, those fast-moving outer stars should have just flown off into intergalactic space a long time ago.
Precisely. The mere fact that these galaxies were holding together meant they had to be anchored by an immense, staggering amount of invisible mass. Now imagine presenting a completely reality-breaking result to a field utterly dominated by men who had built their entire careers on established models. Her findings were, of course, initially dismissed, but Rubin was relentless. Measurement after measurement, galaxy after galaxy, she proved these invisible halos of mass were actually real. By the early 80s, the evidence was simply undeniable.
And yet, she died in 2016, still waiting for the Nobel Prize she so unquestionably deserved. That really remains one of the most glaring injustices in modern science.
So, what actually is this invisible substance that's holding entire galaxies together? Well, the deeply humbling answer is, we only really know what it isn't. It emits no light, it absorbs no light, and it reflects absolutely nothing. It doesn't interact with electromagnetic radiation at all. We only know it exists purely because of what it does. Its immense gravitational pull is very real, it's measurable, and it literally shapes the structure of the universe by bending the light of distant galaxies around it. How do you even begin to hunt for a ghost like that? Physicists have gone to unbelievable extremes. The leading hypothesis for a long time has involved particles called WIMPs, weakly interacting massive particles. To try and catch them, scientists have built these incredibly sophisticated detectors, buried them miles deep underground to shield them from cosmic radiation, and cooled them to near absolute zero. They are basically just sitting there, waiting for the faintest possible whisper of a WIMP bumping into ordinary matter. Wow, so after decades of searching in these hypersensitive deep underground labs, what have we actually found? WIMPs? Nothing. Axions? Nothing. Sterile neutrinos? Nothing. Some scientists even proposed rewriting the laws of gravity itself with a theory called MOND, but that fails on other observations. The humbling reality is that decades of searching have found absolutely nothing. We've really only managed to produce increasingly precise limits on what dark matter is not. And you know, this actually brings us to a question with even higher stakes. We are escalating from what the universe is made of straight to its ultimate fate. Back in 1998, astronomers were trying to answer what seemed like a fairly straightforward accounting question. Is the expansion of the universe slowing down? Which makes complete sense. Ever since the Big Bang, the universe has been expanding. Logic dictates that the collective gravity of all this matter, whether it's dark or ordinary, should be acting like a giant cosmic brake, slowly pulling everything back together.
Right, so two independent teams set out to measure exactly how hard those brakes were being applied. And what they found completely defied all known physics. The expansion of the universe was not slowing down at all, it was speeding up.
Wait, speeding up? But
Gravity pulls things together. Literally nothing in known physics pushes the universe apart on a cosmic scale like that. How could he possibly be accelerating?
They gave this mysterious outward push a name: dark energy. And it is fundamentally different from dark matter. It doesn't clump together, it forms zero structures. It appears to be an intrinsic property of empty space itself. It exists everywhere, and it's causing the very fabric of the universe to expand at an accelerating rate.
Well done. Isn't that exactly what Albert Einstein proposed with his cosmological constant? Like the very concept he later called his greatest blunder?
Yes! It turns out Einstein's so-called biggest blunder was actually perfectly correct.
So what does this constant, unstoppable acceleration mean for the end of time?
The consequences are profoundly sobering. If dark energy just keeps pushing space apart, galaxies will eventually accelerate away from each other until they disappear completely beyond the cosmic horizon. Trillions of years from now, the night sky will be pitch black. Stars will burn out and die. All structure will dissolve. The universe will cool toward absolute zero, becoming a cold, dark, expanding emptiness. A universe that simply forgot it was ever alive.
Okay, that is a genuinely terrifying thought. Can we please pull back from the distant, freezing future for a second? Because if dark energy is the force that's relentlessly tearing everything apart, we have to look at the observable universe right now and ask, what did dark matter actually build? Well, if you could somehow step completely outside the universe and look at the whole thing, you wouldn't just see a random scattering of galaxies. You would see a structure of breathtaking complexity. A vast, three-dimensional web of glowing filaments, incredibly dense nodes, and enormous dark empty voids.
It really looks remarkably like a neural network, doesn't it? Or maybe some massive fungal structure grown to a cosmic scale. It's incredibly intricate and absolutely not random.
Exactly. The universe has a very distinct, deliberate architecture, and the silent, invisible architect holding this entire structure together across billions of light years is dark matter. Think about it like this. Just fractions of a second after the Big Bang, ordinary matter was way too hot and diffuse to clump together. If it had been left totally alone, radiation pressure would have just smoothed it all out, leaving behind a featureless gas totally incapable of producing stars. But dark matter doesn't interact with radiation, so it was free to start clumping immediately, forming this immense, invisible gravitational scaffolding.
Oh, wow. So without that invisible dark matter clumping together first, ordinary matter would have just stayed a giant cloud of featureless gas? No stars, no galaxies at all?
Right. Ordinary matter only later fell into this invisible web. Galaxies formed inside those massive dark matter halos. Stars finally ignited. Planets formed. Life emerged. Every single structure in the visible universe exists strictly because of the gravitational pull of something we cannot see, cannot touch, and simply do not understand. Your existence, the existence of everything you have ever known or loved or wondered about, is fundamentally built on a foundation of darkness.
It really makes you feel profoundly small, doesn't it? But in the best possible way. We are just this tiny, visible byproduct. The cosmos is not primarily made of the things we can see. The universe, it turns out, kept its absolute greatest secrets hidden in the dark.